Well, good morning, class. Good morning, everyone. So, am I audible and visible? I hope that we'll stay till the end. I hope that will give the answer to the queries. Good morning, everyone. Good morning, everyone. Okay. Good morning. So, students, let me know one thing that did you watch those previous lectures of mole concept? I told you that we have done some basic questions out there. Have you done those questions, all of you? Okay, great. Great, very good, Bache. Very good. Good one. So, great, very good. So that is like something which is required. उसको कर लेना अच्छे से ना. So we'll begin today with something called empirical formula and empirical weight. Can we begin that? And in the middle, I'll keep on doing certain questions which are like relevant for the previous discussions. Okay? Chalo, we'll do it. Hai na? Chalo, we'll do it. Come on. So the topic is empirical formula and empirical weight. So let's begin with the molecular formula first of all. So for example, I'm taking three examples: C6H12O6, C5H10O5, and C2H4O2. This is nothing but acetic acid, CH3COOH. This thing is nothing but CH3COOH. Now see, these are different molecules. For example, this is glucose and that is, say, acetic acid. So the three different formulas. Now, what is an empirical formula? Empirical formula is the simplest possible ratio, integral ratio of atoms present in any molecule. That is called empirical formula. So what did I say? C2H4O2. Okay. So if I divide this by 6, this by 5, and this by 2, which are the common factors out here, so I'll get the empirical formula, which will be CH2O, CH2O, and CH2O. Everyone getting that? Harika, it is CH2O2? No, it is CH2O. Check it out. All of you getting CH2O? All of you? The simplest possible integral ratio. Simplest possible integral ratio of the atoms present in a molecule is called empirical formula. Great. Now what I'm saying, can I say that molecular formula can be written as empirical formula into some integer? This integer out here is 6, there it is 5, and there is 2. If I want a molecular formula, I'll multiply basically by a desired integral value, 6, 5, 4, 2, whatever it is, like say. So I'll get a corresponding molecular formula. Is that okay? Yes or no? बोल ही नहीं रहे तुम लोग यार कुछ. ठीक है. And every molecular formula will have a molecular weight. So can I say that molecular weight will be equal to empirical weight into n. N is an integer. So these few things can set us apart while handling that stuff. Okay? Yes or no? So how can we decide integer? No, they will give it to you. They will give it to you. That what do you want? Okay? Science वाला, अभी सब के सब physics वाला, chemistry वाला, science वाला सब वाला हो रखे हैं, chart वाला. अभी कुछ तो सोचो, कुछ तो इनोवेटिव सोचो. ये क्या अपना नाम रखा हुआ है? तुम साइंस के स्टूडेंट हो, तुम कॉपी कैसे करते किसी को? डोंट कॉपी एनीवन. You need not become a photocopy of someone. Are you getting it? साइंस वाला. Put some unique name. Think something unique. कब तक ऐसे हम चलते रहेंगे? हंशिका, इतना अच्छा नाम है हंशिका. ये क्या साइंस वाला, चाट वाला, पकौड़ी वाला, क्या समोसे वाला, क्या नाम रखा है? अभी हेलो किट्टी. ये कैसे कैसे नाम है तुम्हारे? किट्टा किट्टी. सबके अच्छे अच्छे नाम होंगे, पापा मम्मी ने तुम्हारे बहुत अच्छे नाम रखे हुए हैं, तो क्या कर रहे हो तुम लोग? क्या नाम रखे तुम लोग यार? तुम्हारे पापा मम्मी को पता है ये तुम्हारे नाम है तुम्हारे? चलो आ कम. Okay, let's do some questions and we'll begin with that. Come over here. Come. So the question is that, acha, before I give you any question, a preview of that. But whenever they give you, like say percentage, whenever they give you percentage, always begin with 100. Always begin with 100. You can begin with X, Y, Z, whatever. But if you begin with 100, your maths will become very easy. Your maths will become very easy. Yes or no? Let's see that. We'll do that stuff. So I'm giving you, question is that a hydrocarbon contains 80% carbon by weight and rest is hydrogen. Getting it? So find the empirical formula. Find the empirical formula of the hydrocarbon. So whenever they give you percentage, begin on 100. Let this hydrocarbon is having a weight of 100 gram. So out of that, carbon will be, the weight of carbon will be 80 gram and this will be 20 gram. Yes or no? Yes or no? And since I told you, weight is the least important thing. Weight is the least important thing in the world of physical chemistry. Immediately convert weight into what? Moles. So I'll go with the number of moles, which is equal to what? 80 upon 12. Weight upon atomic weight. 20 upon 1. This N will be 6.6. This will be 20. Now to get the empirical formula, we need what? We need what? We need simplest possible ratio. Simplest possible ratio. Now to get simplest possible ratio, divide both these numbers by the smallest number among them. By the smallest number among them. The smallest is 6.6. So I'll divide it. I'll get 6.6 upon 6.6 and it will be 20 upon 6.6. Are you getting it? So immediately I'll get 1. The reason for dividing by the smallest possible, that immediately I'll get the simplest possible number, that is called 1. And this will be approximately 3. Getting it? Try to get to the nearest possible integer. So that means 1 carbon atom and 3 hydrogen atom. So empirical formula will be CH3. CH3, and if they ask you what is the empirical weight, it will be 12 plus 3 coming from hydrogen. It will be 15. Yes, very good, bacho. Very good. Very good. CH3, CH3, CH3. Good. Very good. Very good. Good. Okay. So here 15. Now the second part of the question says, beta, that if the molecular weight is given as 30, they're saying find molecular formula. Find molecular formula. So how you find it out? I know that molecular formula is equal to empirical formula into N. Some integer, so I know that N will be like molecular weight. This is molecular weight and empirical weight. Molecular weight upon empirical weight. 30 upon 15 will be equal to what? 2. Will be equal to 2. So Hansika, you got it now? That how we'll decide that N will be what? N will be 2. Got it, beta, Hansika? Got me? Very good. Very good. Amrutanand, very good. Okay, beta. Okay, chalo. So now the molecular formula will be what? Empirical formula CH3 into 2. It will be C2H6. C2H6. I hope everyone got that. Okay, here we got Gautami has the answer. Srikara has got the answer. Pavitra got the answer. Harshit got the answer. Amrutanand got the answer. Okay, good. Surya got the answer. Very good. Very good. Shall I move ahead, beta? Can I move ahead? We'll do one more question. Chalo, Ajo, come. So again, the same question. A hydrocarbon CXHY, and they're saying that it contains 75% carbon by weight. 75% carbon by weight, and rest is hydrogen. Find the empirical formula. Dekho bachcho. Whenever they give you percentage, begin with 100. The total weight is given as 100 out of this carbon and then hydrogen. So weight is given as 75 gram and this is given as 25 gram. Okay, now weight is the most useless thing in the world of physical chemistry. I'll get number of moles 75 divided by 12, 25 divided by 1. This will give me 6.25 and this is 25. Okay, now I'll do what? To get the smallest possible number, I'll divide both of them by 6.25, which happens to be the least number among them. This will be 6.25 divided by 6.25, 25 upon 6.25, 1, and this will be 4, exactly. So that means I have got 1 carbon and 4 hydrogen. So the empirical formula will be simplest possible CH4. CH4, yes or no? Very good, Gautami again. Vinakonda, Harita, very good. Okay, Pavitra there, Mahesh Babu, Zamir. Arey yaar, sabka hi aa gaya to. All of you got the answer. So I was unnecessarily solving it. Good one, very good, very good. Now the second part is that the valid molecular formula can be first CH4, second C2H8, third C3H12, fourth all. What is the answer? Come on, be quick. Simple question hai. Be quick. Okay. So the answer is CH4. These two are simply not valid formulas. They are not valid. They don't exist. Are you getting it? They don't exist. So be careful with that. For that, valency of carbon will become 5. After CH4, the next compound in the alkane series will be C2H6 and not C2H8. Either this will be C3H8. Are you getting it? So you have to be very, very careful. Valency has to be 4. If you'll find this out, C2H8 is simply not possible. Hai na? How will it be possible? C, H, 1, 2, 3, 4, 5. Again, it is not possible. So idea is that don't get stopped at mathematics. Finish off the chemistry. So put chemistry first. Math should come later on. But many people put the chemistry at the backstage and math in the forefront. So they will get some answers wrong. Okay? Okay, done. Now, बच्चों एक और चीज सुनो बच्चों. It's very important. Whenever they give you freedom to have equal weight, that will give you that X and Y have got equal weight. So you are free to choose any weight. You can choose, sir, I'm choosing A and B are giving, I'm choosing X gram, maybe Y gram, maybe 100 gram and 100 gram or whatever. But my recommendation, bachche, will be that please choose that equal weight as the LCM of the atomic weight of the A and B. LCM of A and B, atomic weight of A and B. That way your maths will become very simple. The idea is to keep the mathematics very simple. Are you getting it? देखो बच्चा जाओ. I'm giving you a question. A compound contains equal weight of sulfur and oxygen. Equal weight of sulfur and oxygen. Find their empirical formula. Okay, so I'll do with that. Sulfur and oxygen. Their atomic weights are what? 32 and 16. So the LCM will be 32. So I'll take weight as what? 32 gram and 32 gram. Whenever they give you freedom to choose equal weight, please choose the equal weight as LCM of their atomic weights. Okay? So now weight is the most useless thing in the world of physical chemistry. Convert into number of moles. So 32 divided by 32 and 32 divided by 16. This will be 1, this will be 2. Your maths will become very simple. Very simple. So that means 1 atom of sulfur and 2 atoms of oxygen. Agree or not? So the empirical formula will be SO2. Are you getting it? It will be SO2. श्योर? चलो एक और लेते हैं. A compound contains A and B in the equal weight. A compound contains equal weight of A and B, and atomic weight of A is given as 20 and that of B is given as 30. Find the empirical formula. That is present, I mean, but keep it. We won't require that stuff. ठीक है? So 20 and 30. चलो, find the empirical formula. So please take the LCM of 20 and 30. It will be 60. So it will be 60 gram and 60 gram. Yes or no? Then number of moles can be weight upon molecular weight. 60 upon 20 and 60 upon 30. This will be 3. This will be 2. So A3 and B2. A3 B2, A3, B2. No, Gautami, it will be A3, B2, beta. A3, B2. It's not A2, B3. Be careful. Sumajra. A3, B2. हर्षित ठीक है. क्रिस क्रॉस. हाँ, क्रिस क्रॉस भी है. So, like some of the students are saying that I have taught them earlier, that there's a trick for that also when they give you equal weight. So when they give you equal weight, rather than doing this thing, you can also do one trick is there, and that is like they give you A and B, you take the atomic weight 20 and 30 and then cross multiply. Whenever they give you equal weight, this will become A 30, B 20. Now simplify that thing. You get A3, B2. Are you getting it? You can do that way also. Rather than doing this thing, when they give equal weight, cross multiply by their atomic weights. Zapfu got it? चलो आ जाओ. So, boys and girls, I told you that what is empirical formula? It is the simplest ratio of the atoms present in a molecule. Simplest ratio of atoms. Here they were giving me weight. Weight is least important. So I was converting the weight into what? Number of moles. Yes or no? And I know that number of moles are proportional to number of atoms. Yes or no, beta? So ratio of number of moles is also ratio of atom. But weight ratio is not the mole ratio. We know that or not, everyone? Empirical formula is the simplest ratio of atoms present in a molecule. In these questions, they were giving us weight. Weight is useless. So we're converting the weight into what? Number of moles. Now, ratio of mole is also the ratio of atoms. Agree or not? So I'm giving you a question that in a molecule, the number of chromium atoms are given as 3.2 into 10 to power of 4 atoms of chromium, and oxygen is like say 4.8 into 10 to power of 4 atoms of oxygen. I'm saying in a molecule, in a compound, what is happening? 3.2 into 10 to the power of 4 atoms of chromium and 4.8 into 10 to the power of 4 atoms of oxygen. Find the empirical formula. Yes or no? So take the ratio directly. It's the ratio of atoms. So this will go 3.2, 4.8, 16, 2 and 16, 3. So CR and O ratio is 2:3. So chromium has got 2 atoms, oxygen got 3 atoms. It will be Cr2O3. Are you getting it, beta? So many people sometimes they get confused because most of the booklets contains the weight. But if they give you directly number of moles or number of atoms, getting it? Take the direct ratio. It is only with the weight we have problem. Weight is the most useless thing. All of you getting it? Vijay, Harsha, science wala. Okay, good one. Chala jao. Okay, now we'll do one more question. Say a compound containing 2.20 gram 2.20 gram of a compound containing, or it contains uh, phosphorus and sulfur, and it contains 1.24 gram of phosphorus, 1.24 gram of phosphorus, and rest is sulfur. Find the empirical formula of the compound. Find the empirical formula of the compound. Come on. 2.20 gram of a compound contains 1.24 gram of phosphorus and rest is sulfur. Find out the empirical formula. Come on. Done. देखो, this will be 0.96 gram, है ना? This is weight, है ना? And weight is most useless thing. So I'll go with what? Number of moles. 1.24 upon 31. The atomic weight of phosphorus is 31, and this will be 0.96 upon 32. Yes or no, beta? I mean, this will be actually 0.04 and 0.03. But this is not a simplest ratio. I can multiply by 100. This will become 4 and this will become 3. So the formula will become P4S3. P4S3. Very good, bachcho. Very, very good. Good. Pavitra, Sumajra. Good, very good. Here we got Nayan, good. Aditya, good. Shrikara, good. Satya Rao, good. Zamir, good. Vivek, keep it up. Getting it? Okay. So here we go, and let's have, this is the empirical formula and molecular formula. Okay. चलो बताओ. 0.5 mole of K4 FeCN6. 0.5 mole of K4 FeCN6 will contain how much weight of carbon? 0.5 mole of K4 FeCN6 will contain how much weight of carbon? Come on. I know one thing, that 1 mole of this compound contains 6 mole of carbon. So 0.5 mole will contain 3 mole of carbon. Yes or no? Very good. And 3 mole of carbon, the weight will be 3 into 12. Number of moles into atomic weight will be equal to 36 gram. It will contain 36 gram of carbon. Yes, very good. Contain 36 gram of carbon. Can I? Chalo batao, if I give you C6H12O6, this is glucose and the molecular weight is 180. Glucose molecular weight is 180. Can you find out percentage of carbon by weight here? Percentage of carbon by weight. Come on. Percentage of carbon by weight in one molecule of glucose. Come on. So this contains, if I talk about weight of carbon, by 1 carbon contains 12. 6 will contain 6 into 12. That is equal to what? 72. If you take it 180 gram, this will be 72 gram. So the percentage of weight of carbon will be 72 into 100 divided by 180. Out of 180, 72 gram is there. So percentage will be Gone. 18, 4 into 10, 40%. It will be 40%. Very good. Very good. Very good. Acha, who will tell me the percentage by weight of hydrogen? Percentage by weight of hydrogen. Who will tell me? There are 12 hydrogen. 1 mole of hydrogen contains 1 gram. 12 will contain half weight. Very good. So I know that weight of hydrogen will be 1 into 12 equal to 12 gram. So percentage of hydrogen will be 12 into 100 divided by 180. Gone. 6263. 20 by 3. 20 by 3 will be 6.6%. 6.6%. Very good. Good. Harita beta, it's not 3.3, it will be 6.6. Good. Very good. 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 Shrikar, Vagadevi, Harika, Satyarao, Harry Potter, विजय, इस सब के सब विदेशी हो रखे. हैरी पॉटर, ठीक है भाई. अच्छा, who will tell me the percentage of oxygen? Percentage of oxygen, बोलो. There is no need to calculate that. You can simply do 100 minus this plus this. Remaining will be oxygen only. 100 minus 40 minus 6.6. You will get 53.4%. You know? 53 point, remaining will be oxygen. Good, very good, bachche. Very, very good. Excellent. Great. Chalo. So, this part is over. So let us learn how to, this is important one, which is coming one, how to balance the chemical reactions of combustion of hydrocarbon. So remember that any hydrocarbon, typically made up of carbon and hydrogen, will burn an oxygen to give you CO2 and H2O. CO2 and H2O. Be very careful, bachcho, है ना? Be very careful. Acha, now see that. We'll balance few equations, है? So we have, say, for example, CH4 will burn an oxygen to give you CO2 plus H2O. In order to balance these kind of equations, students, first of all, these are called combustion reactions. First of all, balance carbon. Once carbon is balanced, then try to balance hydrogen on both the sides. And then we'll balance oxygen. So let's learn by some examples. Okay? Chalo. So one carbon is balanced, no problem. 4 hydrogen, 2 hydrogen. I should multiply this by 2. So 4 here, 4 there. Okay? Now balance oxygen. There are 2 atoms and 2 into 1, 2 atoms. Total becomes 4 atoms. I need 4 atoms of oxygen here also. Getting it? So multiply this by 2. The idea is that the number of atoms here, divide that by 2, you'll put that number out here. So 4 by 2 is 2. So 2 will come here. Let's take some more examples. Like say C3H8 plus O2 giving you CO2 plus H2O. Balance first carbon. Carbon will be 3 CO2. H8, 4 H2O. Then balance oxygen. 3 into 2, 6. 4 into 1, 4. Total becomes 10. 10 oxygen atoms. Divide 10 by 2. 5. That's the balance equation of the combustion reaction of propane. Okay, let's see next one. So we are having C5H12 O2 giving you CO2 plus H2O. Very good. So this is 5. I'll put 5 CO2. 12 hydrogen. I'll make it 6. Now 5 into 2, 10. And 6, 16. 16 oxygen atom. Divide this by 2. I'll get 8. 8 O2. Getting it? Harika, very good, bache. Zamir, very good. Keep it up. Now, Harika, it will be 8 O2. Shall I? Understood? Now, a very important thing, bachcho, a very, very important thing, understand that for gases, volume is equal to number of moles into 22.4 liter. Yes or no? Now, this will be constant every time. So, can I say volume is proportional to number of moles for gases? For gases, number of moles is proportional to volume of the gas. So, what is the significance of this thing? The significance of this thing is actually that you can treat your volume as moles and moles as volume. Are you getting it? That ratio of volume and mole will be same. Mole ratio will also be the volume ratio. Yes or no, Gudiya? Everyone. When someone says that volume is proportional to number of moles, it means mole ratio will also be the volume ratio. Or it also means that whatever you want to do with the moles, you can do with the volume also. Are you getting it? So this will go a long distance to help you in solving certain questions very easily. Shall we go? Chalo, aajao dekhte hain. Haan, okay. So my question will be out here, na? The question says, it's so simple, bachcho, that find the volume of O2 required to completely burn 3 liter of pentane. This is pentane. Akhila, in offline, but in offline I don't teach in the girls' campus. I teach only in the boys' campus. I teach 12th class girls, but not long term. Okay? Chalo, come on. What I'm saying, this is actually pentane. This is actually pentane. And I told you that question is that how much volume of O2 will be required to burn 3 liter of pentane. 3 liter of pentane. देखो बच्चों, so I know that 1 mole will require 8 mole, है ना? Or can I say that, I mean, instead of mole I can say that 1 liter will require 8 liter, because volume ratio will also be the mole ratio. Can I say that? Sameer, very good. Shrikar, very good. Aditya, very good. Zamir, very good. Pavitra, good. Gautami, very good. Excellent. Hai? So 3 liter will require how much? 3 into 8 equal to 24 liter. You can treat your volume as moles and moles as volume. Their ratio will remain same. Getting it? The ratio will remain same. So you'll get the same answer. Everyone clear with that? Achha, who will tell me that for this question, how much of oxygen will be required to burn 4 liter of this thing? 4 liter of propane. 1 liter requires 5 liter. 4 liter will require 20 liter. Yes or no? Yes or no? So I think that we can handle these questions very easily if you know how to balance it. And balancing, you have become champions now. Yes or no? Okay, chalo. Okay, let's do it now. Let's do some questions. So I'm giving you a question. I'm saying that there is a hydrocarbon and which is going to combust and it will give you CO2 and say H2O and H2O. So what I'm saying, the question they are giving is that 10 ml of hydrocarbon on complete combustion in oxygen gives you 30 ml of CO2 and 40 ml of water. 10 ml of hydrocarbon on combustion gives you 30 ml of CO2 and 40 ml of water. Find the empirical formula of hydrocarbon. Find empirical formula of hydrocarbon. So again, I'm telling you, boys and girls, that you can take your volume ratio as mole ratio. Whatever you want to do with the volume, you can do with the mole and vice versa. Yes or no? Chalo, come over here. So I'll take it, and over here what we'll do, we'll balance carbon first and then we'll balance hydrogen. So can I say that 1 mole of this hydrocarbon contains X mole of carbon? 1 mole of this hydrocarbon contains X mole of carbon. So 10 mole will contain how much? 10x. Yes or no? I'm treating the volume as mole. Getting it? Okay. So, and same amount of carbon should be present there. 1 mole contains 1 carbon in CO2. 30 will contain 30. So, X will be equal to 3. X will be equal to 3. Very good. Very good. But are you getting that, all of you? All of you getting that? Very good. Now come over here. Balance now hydrogen. 1 molecule contain, or 1 mole contains Y. Hydrogen. 10 will contain 10Y. Now come over here. Hydrogen. 1 contains 2 hydrogen. 1 mole contains 2 hydrogen. 40 will contain 40 into 2. 40 into 2. So Y will be equal to 8. So the empirical formula, bachcho, will be C3H8. And it is the simplest formula. We cannot simplify it. So this will be the empirical formula. Yes or no? Yes, good. Very good. So boys and girls, all of you getting that? All of you? Is that clear to all of you? So we'll quickly do one more question. We'll do quickly one more question. फटाफट से करते आओ. CXHY plus बच्चे O2 दूंगा. O2 giving you CO2 and H2O, and they're saying 5 ml will give me 20 ml and 15 ml of water. Find out the empirical formula. Find out the empirical formula. Be careful. Find out the empirical formula. Come on. Good. So here again, please balance carbon and balance hydrogen. Boys and girls, getting that or not? Come on. All of you, please. So let me check who is getting the right answer. Be careful, Gautami, be careful. 1 molecule of water contains 2 hydrogen. Remember that. Chalo, dekho. 5x will be equal to 20. X will be equal to 4. No doubt about it. Hydrogen. 5 by equal to what? 15 into 2. 15 into 2. 3, 6, y equal to 6. So the C4H6. But this is what? Molecular formula. This is molecular formula. This is not empirical formula. Empirical formula will be simplest one. So empirical formula will be C2H3. C2H3. The first option in this question is C4H6. So I'm telling you, don't stop at mathematics. Complete the question by chemistry. Some people, they stop at mathematics. Don't stop at mathematics. Are you getting it? Yes or no? Chalo. We'll do the last question of the day. Okay. This says that 5-liter mixture of butane and propane. 5-liter mixture of butane and propane on complete combustion. Gives 18 liter of CO2. Gives 18 liter of CO2. Find volume of butane and propane present in the mixture. You have to find out volume of butane and propane present in the mixture. Same concept will be applied, बच्चों. Same concept, है ना? आओ देखो बच्चों. So let's assume that this is x liter, and this will be with how much? 5 minus x liter remaining. And now, since they have given me the data of CO2, so let's have that. C4H10 will give me 4 CO2 on balancing carbon. On balancing carbon, they have given me the data of CO2. So I'll keep on focusing on CO2. Water, they have not given any information, so I'll not look at the water part. Water part. Okay. So 1 liter will give me 4 liter, x liter will give me 4x liter. Similarly, for propane will give me 3 CO2. On balancing carbon, 1 liter will give me 3 liter, 5 minus x liter will give me 3 into 5 minus x liter. कितना आएगा ये? 15 minus 3x liter. Agree or not? Now, this is the total amount of CO2 I got. So total volume of CO2 will be 4x plus 15 minus 3x equal to how much? 18 liter. 18 liter. So this will be 4 minus 3x, x equal to 18 minus 15, x will be equal to 3 liter. That means this is 3 liter and this will be 2 liter. Yes or no? Yes or no, beta? Getting that? All of you getting that? So that is all for the day, beta. Please try to revise it, and in the next class we'll be doing more questions on the stoichiometry, but they will have some relationship out here. So please do these questions properly, and I wish you all the best. God bless you. Wish you a happy weekend, but enjoy, but still study, bachcho. Okay? Bye, bachcho. Bye-bye. That I don't know. This week's syllabus I do not know, but I believe that next week you will be having test. This Sunday there is no test, I believe. Okay. We'll do those questions, Vivek, next time, है ना? Okay. Chalo. Okay, bye, bachcho. Bye-bye. Take care. Bye. All the best.